Now coming to the last part of the glycerol, we are having the reactions of glycerol with different oxidizing agent. So first let me write the reactions and then I will explain you what are the different oxidizing agents you will take, and as a result the different product you will be getting it. Okay, so glycerol CH2OH, single bond CHOH, single bond CH2OH. Now first, when we oxidize it in the first step, see this carbon will get oxidized, the primary carbon, this is primary, this is secondary and tertiary. Sorry, this also is primary, I am very sorry, this is primary. So primary 1 degree, 2 degree and again 1 degree, we can say that. Got it? Alpha, beta and alpha dash we can say, or alpha, beta, alpha dash. Okay. So you know that primary carbon, this and this, gets oxidized to aldehyde. Aldehyde gets oxidized to acid. And the secondary carbon get oxidized to what? Ketone. Because this is secondary alcohol. This one, isn't it? This is secondary carbon which contains OH group. So secondary alcohol gets oxidized to what? Ketone. We have already studied in alcohol chapter. So coming to it, see what I will be getting it. CHO, this first carbon, primary carbon, CHO, then CHOH, then CH2OH. What is the name? It is glyceraldehyde. Glyceraldehyde. This is glycerol to glyceraldehyde. Now next, again the same, CHO will be oxidized to COH, single bond CHOH, single bond, that is CH2OH. So this is your glyceric acid. We can say that glyceric acid. Clear? CHO gets oxidized to COH. Now you see. Now next is, I'll be doing it this way. So oxidizing it. So what will happen? CH2OH. Now the secondary carbon will get oxidized to ketone. Just now we said you, because the secondary alcohol. Now you will be getting CH2OH. So what is the name of this compound? Dihydroxyacetone. Now acetone is what? CH3COCH3. So instead of one H, OH is there. Here also instead of one H, OH is there. So it's, how many OH? 2 OH. So hence it is dihydroxyacetone. It is said to be S. Now this will oxidize. Alright, now when this will get oxidized, this particular one, here what it happens is that you can see here water molecule is released, HOH. You can see water is released. I can write it here, minus water. Now when this will get oxidized, it will get oxidized to what? COH, single bond C double bond O, then COOH. You can see this carbon gets oxidized, primary carbon, these two primary carbon now gets oxidized to what? That is carboxylic acid, aldehyde to acid. In one step I have written it. Fine. Now glyceric acid, let me write it smaller because otherwise I will not get this place. Glyceric acid. Now this will oxidize. Now this carbon is already oxidized. Now this particular carbon, got it? COH, single bond CHOH, single bond COOH. This carbon, this primary carbon now gets oxidized. Alright, already this was oxidized, that is there. Now this secondary carbon remains as it is, and primary carbon again, this is getting oxidized. So what is this known as? Tartonic acid. This is called as tartonic acid. Now you can see that this particular one, if I oxidize it, COH, that is tartonic acid, what will I get? Here you can see again the water is removed, C, H2O, the water is removed here. And hence what I get it? C double bond O. Again the secondary carbon is oxidized. If I oxidize this one, if I oxidize this, the secondary carbon gets oxidized to, what is that? Ketone. Fine. COH remains the same. Fine. Now what is the name of this compound? It is said to be as mesoxalic acid. I am writing it here. Mesoxalic acid. This compound name is. Now next is here, if I further oxidize this one, then what I am going to get it? COH, single bond COOH. Alright, you know what is this compound? Oxalic acid. And what happens to this CO group? CO group oxidizes with the oxygen to form here carbon dioxide. This oxygen, CO, now CO is unstable, it oxidizes to form carbon dioxide, which is released, and we get oxalic acid. From mesoxalic acid we get oxalic acid. If you further oxidize it, then what I am going to get it? Carbon dioxide and water. So ultimately I got carbon dioxide and water. Got it now name? Now in the exams you will be getting convert glycerol to glyceric acid, convert glycerol to mesoxalic acid, convert glycerol to oxalic acid, carbon dioxide and water. So you can see when I oxidize to carbon dioxide and water, so completely glycerol is oxidized. So this has to be done by very strong oxidizing agent. So what is that? I have to take acidified KMnO4. Alright, then only it can be possible. Now if I take dilute nitric acid, if I take it, then I will be getting what you can say, that is nothing but glyceraldehyde or up to glyceric acid. If I take concentrated nitric acid, I will be getting, that is nothing but dihydroxyacetone or up to mesoxalic acid, you will be getting it. Clear? Now if I take Fenton's reagent here or bismuth nitrate. Now Fenton's reagent is what? Fenton's reagent is nothing but FeSO4 plus H2O2. Then you will be getting a mixture of glycerose. Glycerose, Glycerose. Glycerose is something but a mixture of dihydroxyacetone and mesoxalic acid. That's said to be S. If I take Fenton's reagent, FeSO4 plus H2O2, it acts as an oxidizing agent. Then I will be getting it. So in this way, different oxidizing agent will give you different product. And also it depends upon the question how much it is coming. Whether it is coming up to glyceric acid, you have to write this. Whether it is coming to dihydroxyacetone, you have to write this. Whether it is coming to oxalic acid, you need to write this and this one. So you need to practice this one. Okay, fine. Now next, after that, if I take, as I said you just now to you, if I take acidified KMnO4, if I take it, acidified KMnO4, then see here. So glycerol, CH2H, single bond, CHOH, single bond, CH2H. Just now I said you that is acidified KMnO4, that is KMnO4 slash H plus. Alright, that is nascent oxide will give you, what I said you, this two will get oxidized to, primary will get oxidized to what? Oxalic acid. Isn't it? And the secondary one will be oxidized to carbon monoxide. Carbon monoxide further oxidizes to what? Carbon dioxide, and water is released. Here see HOH, water is released, this water. And what is being there? C reacts with oxygen to form CO. But carbon monoxide is unstable. Ultimately it will get oxidized to carbon dioxide and water. That's it, in this way. Clear? Now if I take here, that is instead of KMnO4, acidified KMnO4, if I take here periodic acid, that is HiO4, which is periodic acid, is also a strong oxidizing agent. Then here the cleavage takes place here. Cleavage takes place here, we can say that. So here this is alcohol, it will get oxidized to what? Aldehyde, HCHO. Alright, this alcohol, primary, both are primary, it will get oxidized to what? Aldehyde, HCHO. Alright, and the secondary carbon, this will get oxidized to what? Ketone. You know that secondary alcohol get oxidized to ketone. Ketone on further oxidation will give you what? Carboxylic acid. So hence you will be getting HCOOH. Understood? This one primary, this two, it will get oxidized to alcohol to aldehyde. This is secondary carbon, secondary alcohol, which will get oxidized to ketone. I told you many times. Ketones on further oxidation will give you what? Carboxylic acid. So hence you get carboxylic acid. Alright? And this particular one, HiO4, oxidizing agents, it will get reduced into HiO3 and water. Because oxidizing agent oxidizes these substances, but itself gets reduced. From per iodic acid, it will give you iodic acid. From per iodic acid, it gives you iodic acid. Okay, fine. In this way. Now, next, after that, we will come to dehydration reaction. Alright, so here the dehydrating agent which I will be taking, it is either potassium bisulfate, KHSO4, or I will take phosphorus pentoxide, or I will take concentrated sulfuric acid. Alright, either of this. So what I will do is that here I will make it much more easier for you. I will be writing the structure completely. I will write the structure so that it will be easier for you to understand. Alright, now I will take here potassium bisulfate, KHSO4, potassium bisulfate, which also acts as a dehydrating agent. Or I can also take concentrated sulfuric acid or P2O5, phosphorus pentoxide. So what will happen? Dehydrating means water is removed. See here. For that reason I wrote it, because it will be easy for you to understand it. See here, HOH is removed. Then what is remaining here? CH2, double bond C, here C is left. Here also same thing, double bond C, because carbon has to be 4 bonds. And here you will be getting what? CHOH. But this is unstable, because dienes, which is not stable. Diene means with one carbon atom you are having 2 double bond, which is not stable. So hence it will undergo molecular rearrangement. You have studied in class 11. Molecular rearrangement is otherwise known as tautomerism, where this bond will come here, got it, to this particular oxygen. It is going to come, and this hydrogen will be reaching here to this particular carbon. So hence what I am going to get it, CH2 double bond CH single bond CHO. Got it? It is CHO, CHO, so it is left, see, H goes here. So CH2 double bond CH single bond CHO. What is this known as? It is known as acrolein, acrolein or acraldehyde. It is said to be as acrolein or acraldehyde. Now let me tell you that this particular reaction is a test for glycerol. Why? Because this acrolein or acraldehyde has got a very offensive smell. Very offensive smell, very bad smell. Bad smell means you might have experienced the smell in the public toilet, or in the what you can say, in the train, in the what you can say, that is a washroom which is there in the train, the toilet which is there in the train. You have experienced the smell there. So that sort of smell you will be getting it here. It's a very bad smell, very offensive smell. So hence this particular formation of acrolein is a test for glycerol, because glycerol only gives this particular compound. Glycerol on dehydration only gives this particular compound. So this particular reaction is a test for glycerol, that is acrolein or acraldehyde, I should say that. Clear? This reaction. Now next is, we have also got another test, that is said to be as Dunstan's test. Dunstan's. Now what is this Dunstan's test? Now in Dunstan's test, what I need to do is that I will be taking, that is, listen carefully, I will be taking a test tube where I will add, that is, phenolphthalein, few drops. Then I will add borax solution into it, Na2B4O7. Alright, borax solution, I'll add it to it. Then what you'll find is that it will become pink color. Now when I add few drops of glycerol to it, then the color will get decolorized. The pink color will get decolorized. But if I heat it, this solution, alright, again it will become pink color. But if I cool it again it gets decolorized. Alright, listen carefully what I said. I will take a test tube, I will add some phenolphthalein into it, then I will add some borax solution into it. Borax solution, Na2B4O7, borax. By doing so, what happens is that it becomes pink color. Now if I add some glycerol, few drops of glycerol into it, it becomes colorless. It becomes colorless. But if I heat it, the solution, again it regains back its color. That is, again it becomes pink. And on further cooling, again it becomes colorless. So this particular test is given only by glycerol, which is said to be as Dunstan's test. So you got two tests. One is the acrolein, another is your Dunstan's test. So this two tests is a test for glycerol. Okay. So that's all we have from the glycerol chapter. Thank you very much.